Good day everyone. Welcome again sa vector analysis, and today we'll be discussing position vectors. Okay, so marami na tayong na-discuss sa mga previous videos natin about vectors. Okay, and kakatapos lang natin ng mga space coordinate systems. So ngayon naman, we'll discuss position vectors. Ano ba yung mga position vectors and ano yung advantages ng paggamit ng position vectors in analyzing in solving problems relating to vectors. Okay? So simulan na natin. So let's define ano ba yung position vector. A position vector is defined as the vector connecting a reference point and a location or position in space. Halimbawa, so meron tayong points, point 1 to point 2, point 3, point 4, point 5, point 6. We can uh, define a vector using these points and a reference points to describe a particular point in space. Okay? So the position vector always points to the position it identifies. So ito yung example natin dyan. So in this case, yan, we have point 1 given by Cartesian coordinates x, y, and z. That's a point in space. So usually, ginagamit nating reference point is yung origin ng Cartesian plane, which is 0, 0, and 0, di ba? So pagka ganyan, we can now define a vector from the origin going dun sa ating point. Okay? So if we have 2 points, we can now define 2 separate position vectors for points P1 and P2. And we can also define the vector connecting these points. Okay? For example, yung point 1 natin is yung ating tail, and yung ating point 2 yung ating head. Okay? So, nandyan yung arrowhead niya. We can say that vector A, which connects point 1 hanggang point 2, it is equal to the position vector of the head, which is in nasa point 2, minus the position vector nung nasa tail, which is nasa 1. Okay? So, yan yung gamit ng mga position vectors. We can now represent a vector in 2 different points in a space coordinate system, specifically in Cartesian, using points and using position vectors. Mas madali siya. Okay. So let us illustrate some examples in solving problems using position vectors. So ayan. Consider 2 points are given in the Cartesian coordinate system as point 1 given with x niya 1, y is equal to 1, and z is equal to 3. And then point 2 with x equals to 3, y equals 1, z equals 3. We are to find the vector connecting point 2, which is yung ating tail, and to point 1, yung ating head. So lagi natin tatandaan kung nasan yung tail and head. Kasi yan yung magdi-dictate ng ating formula. Okay? So, yan. So, paano natin gagawin yan? So, the approach is that we are going to solve this problem in two ways. Okay? Meron tayong dalawang pwedeng solution. First solution, yung ginagamit natin dati, to solve natin to using our formula sa vectors. Okay? And then second, yung sa position vector. Yan. So, dito, illustrate lang natin yung points. Medyo pangit lang kasi yung point 2 nasa mababa. Okay. Anyway, Meron tayong 2 points, yung ating tail nasa point 2 at yung ating head nasa point 1. Lagi natin tatandaan yan. Okay? So first, anong gagawin natin? Solution, let us solve it as regular vector. Ibig sabihin, gagamitin lang natin yung points 2 at saka 1 to solve yung vector na yan. Okay? So ano yung formula na ginagamit natin? Ito. So our vector A is equal to x hat times yung difference ng ating scalar component sa x plus y hat times the difference ng ating scalar component sa y plus z hat times the scalar component sa z. Yan yung alam natin na gamitin na formula, right? So, substituting the values na meron tayo dito, we now have x hat, and then yung ating point 1, 1 yan, okay? Then minus 3, plus y hat, and then 1 ulit, minus 1, plus z hat, 3, minus 3. So, ang mangyari dito, it will become negative 2. Dito naman, 0. Ito naman ay 0 din. Okay? So, ano ang mangyari dyan? Sagot natin is that vector A connecting point 2 to point 1 is negative x hat 2. So, yan. For the second solution, we are going to use position vectors P1, yun yung ating head, and yung P2 sa tail. So, paano naman yun? So, isa-solve daw natin itong position vector na yan, at ito rin position vector na to, 2. Then ito rin, position vector na yan. And then, yung ating vector A is equal to position vector ng head, which is yung 1, minus the position vector ng 2. Okay? So, ganyan daw siya. So, yan yung approach natin. Kailangan kunin muna natin yung position vectors per point. Okay? So, para sa point 1, gagamitin nating reference point is yung ating origin. Kaya yung magiging formula natin ng position vector sa point 1 is equal to x hat times x sub 1 minus yung reference point na 0, which is the origin, plus y hat times y sub 1 minus yung reference point natin, then plus z hat times z sub 1 minus yung ating reference point. Okay? So, substituting the values ng ating x sub 1, yung ating x sub 1 is 1, 1, 3. So, ito 1, ito 1 din, ito ay 3. We now have this. Then, solving the scalar components, we now have our position vector at point 1 equal to x hat 1 plus y hat 1 plus z hat 3. So, yan yung ating first position vector. Then, sa susunod na vector naman, yung point 2, ganun din. No? From 0 to point 2 naman, gagamitin natin yan. Same formula, pero x sub 2, y sub 2, and z sub 2 lang yung ating gagamitin mga values, which are 3, 1, and 3. So, substitute these values to the formula, we now have x hat 3 minus 0, y hat 1 minus 1, and z hat 3 minus 0. So, ang sagot natin dyan would be x hat 3 plus y hat 1 plus z hat 3. So, right now, we have na yung ating position vector 1 and position vector 2, right? So, we are now ready to solve for the vector using these position vectors. So, sabi natin, by definition, yung ating vector connecting 2 points is equal to the position vector ng head minus the position vector ng tail. And Yung ating head is yung ating P sub 1. Yan. And yung ating tail is yung P sub 2. Okay? Therefore, substitute these values. Ganito na siya. X hat 1 plus y hat 1 plus z hat 3 minus x hat 3 plus y hat 1 plus z hat 3. So, mangyari lang dyan, 1 minus 3, 1 plus 1, or 1 minus 1 rather, and then 3 minus 3. Kaya naman ang magiging sagot natin is the same. A is equal to negative x hat 2, which is equal dito sa value na to. Okay? So, ganyan siya. Paano naman kung nasa ibang coordinate system tayo? Like for in this case, we are given 2 points in cylindrical coordinates as P1, 1, 30 degrees, and 1. So yung 1 dito is ating R, phi is 30 degrees, and Z yung ating 1. Ganun din sa point 2, we have R is equal to 2, phi is equal to 0 degrees, and Z is equal to 2. We are to calculate the vector connecting points 1 and 2 in terms of their position vectors of points P1 and P2. So same approach with doon sa kanina. Although, yung problem natin kasi sa ngayon is nasa cylindrical coordinates yung points natin. So our approach is that itong cylindrical coordinates, we are going to convert them into Cartesian plane. Okay? And then solve for the position vectors of points 1 and 2. And then pag nakuha na natin yung vector in Cartesian coordinates, we are going to transform it uh, back to the cylindrical coordinates para makuha natin uh, yung vector in cylindrical coordinates. Okay, so that's the plan. So again, just to remind, yung ating vector A using the position vectors is equal to the position vector ng head minus the position vector ng tail. So, tandaan lang natin yung video natin sa cylindrical coordinates. Okay, yung conversion natin, no? Cartesian. Yan. So, alam natin na yung x natin, x is equal to r cosine theta, y is equal to r sine, x is equal to r cosine phi, rather, then y is equal to r sine phi, then yung z natin is equal lang. Okay? And yung pag-transform from cylindrical to Cartesian is given by this function or equation. Okay? Matrix. So, gagamitin natin yan mamaya to transform yung ating magiging vector in Cartesian. Okay? So, how do we start? Let's start by getting the position vectors of point 1. So, for point 1, yung ating x would be x sub 1 is equal to r sub 1 cosine ng phi sub 1. So, yung ating r sub 1 is 1, then cosine ng 30 degrees. Okay? So, ganyan siya. So, it is equal to, pag cosine ng 30 degrees, that is square root of 3 over 2. Therefore, yung ating x sub 1 is equal to square root of 3 over 2. Okay? Then, for y sub 1 naman, it is equal to r sub 1, then sine of theta sub 1. It is, ano yan? So, y sub 1 is equal to 1 sine ng 30. Ang sine ng 30 is 1 half. Therefore, y sub 1 is 1 half. And of course, yung z natin, z sub 1 is equal to z sub 1. So, ano ba ang value ng z sub 1? 1. So, therefore, c sub 1 is equal to 1. Okay? So, we now have yung coordinates ng point 1. Itong point 1 daw pala ay square root of 3 over 2, 1 half, and 1 sa Cartesian plane. Okay. So, gamitin na ulit natin yung formula natin sa position vector. Ang reference point natin is origin palagi, ha? Para hindi tayo mahirapan. Origin, then points natin, we are now given, right? X sub 1, and Y sub 1, and Z sub 1. So, substitution, we now have this equation. Okay. And then, yung ating position vector sa point 1 has this equation. Okay? So, P sub 1 is equal to x hat square root of 3 over 2 plus y hat 1 half plus z hat 1. So, tabi lang na muna natin yan dito, ha? Tabi lang muna natin yan dyan. Then, kunin naman natin yung position vector ng point 2. Okay? Paano naman sa point 2? For point 2, same formula ng pag-convert from cylindrical to Cartesian. So, yung x sub 2 natin, equal yan sa r sub 2, which is r sub 2, 2 cosine ng 0 degrees. So, x sub 2 is equal to 2. Then, sa y naman, y sub 2 is equal to r sub 2 sine phi sub 2. So, yan naman ay equal yan sa 2 sine ng 0 degrees, which is equal to 0. Okay, so y sub 2 is equal to 0. Then, of course, yung z natin, c sub 2 is equal to z sub 2, which is equal to 2. Okay? C sub 2 is equal to, sundan lang ulit natin yung formula ng position vector sa P sub 2. Then, substitute natin yung mga values na nakuha natin. Sa x, we have 2. Sa y, we have 0. Z, we have 2. Therefore, itong y, mawawala na yan. Matitira lang x and z. So, yung ating position vector at point 2 is equal to x hat 2 plus z hat 2. Okay. Tabi lang ulit natin yan dito. Yan. Tabi lang natin dyan. Kasi gagamitin natin yan mamaya. Okay? Yan. Next. We now have our position vectors. And we are ready to calculate for the vector in Cartesian coordinates. Kaya yun na yung susunod natin gagawin. Kunin na natin yung vector in Cartesian coordinates. So, sabi dyan, i-minus lang daw natin. So, pag minus natin yan, sinubtract natin, ito, subtract natin sa 2, or subtract natin yan, and then 1 half, z, 1. So, substitute lang natin ulit. So, yung ating head is yung ating 2, right? P1 and P2. Then, yung ating tail is yung ating P sub 1. So, simplifying the scalar components, ito na yung ating vector in Cartesian coordinates using yung position vectors. No? So, ito for x hat, 4 minus square root of 3 over 2. So, that is the same with 2 plus square root of 3 over 2. Pares lang yan, no? Then, minus y times 1 half plus z 1. Kasi 2 minus 1. Okay? So, ayan. Dahil nakuha na natin yung ating vector in Cartesian coordinates, ibabalik na natin siya doon sa cylindrical. So, how do we do that? We use our formula in transforming Cartesian coordinates into cylindrical coordinates. Okay, so, same pa rin. So, hopefully, natatandaan nyo pa yung method or yung steps in transforming these coordinate systems. So, paano ba yan? So, okay. So, itong first value, nilagay ulit natin dito sa unahan. Then, itong negative 1 half dito sa second. Then, 1 dito sa third. Okay? So, ganun lang. And then, sum natin itong mga to. Yan ay magiging value ng ating coordinates or ating scalar components ng vector. Okay? So, yan. So, simplifying yung ating transformation, ang value ng ating vector would be A is equal to R, dahil nasa cylindrical coordinates na tayo, R hat times 4 minus the square root of 3 over 2 cosine of phi minus 1 half sine phi. Ito yan. Okay? So, yung third value, 0 lang naman yan. Plus phi hat square root of 3 minus 4. Naging ganyan, nagkabaliktad dahil dito sa negative na to. Dinistribute natin. So, ito naging negative 4. Ito naman naging positive 3. Kaya, nauna lang to sa pagsulat. Square root of 3 minus 4 all over 2 sine of phi minus 1 half cosine ng phi. Then, 0 na yung third term. Plus, ito, 0 na rin to. Ito rin, 0 na rin. Ang naiwan na lang is yung 1. So, z hat 1. So, meron tayong vector in Cartesian and meron din tayong vector in cylindrical. Okay? So, that's it. Yun, no? Uh, we defined yung mga position vectors and yung advantage kung bakit natin kailangan matutunan yan, saan natin gagamitin. We also solved two examples in using these position vectors in different coordinate systems, space coordinate systems. So, magagamit natin itong position vector sa pag-aaral natin ng charges and yung mga fields. Magiging handy itong tool na ito para mas mapadali yung pag-analyze ng mga vectors. Okay? So, in the next videos, we'll discuss naman yung mga vector calculus, like for example, yung line integral, okay? Then mga surface integral, and yung volume, okay? So, yun. Kung meron kayong questions, feel free to ask sa comment section. And kung meron kayong hindi naintindihan, i-comment nyo lang din dyan. So, see you on the next lesson. Maraming salamat.